Hello everyone, this is Manish from Skillable India, and we are into the continuation of our course of geometric dimensioning and tolerancing. In today's session, we are going to learn the most important topic what we have already started this about the material condition modifiers. Okay, so in this we are going to understand about the when to apply MMC maximum material condition, when to apply LMC least material condition, and when the RFS is a default condition. Okay, and when we are applying RFS, so what are the tolerances we get, tighter tolerances we get when we apply the RFS. Okay, so in this session we are going to understand all the concepts of these material condition modifiers with the examples. Okay, so first of all we are going to start with the regardless of feature of size. Okay, so first of all, regardless of feature of size with internal feature. Okay, so whenever I am talking about internal feature, I am talking about whole. Okay, whole. So in this example, as you can see, when we apply regardless of feature of size, when a geometric tolerance is applied on an RFS basis. Okay, whenever we apply the geometric tolerance in the feature control frame in any engineering drawing on RFS basis. Okay, RFS is a default condition. So RFS basis, the specified tolerance is independent of the actual size of the considered feature. Okay, so in this, the specified tolerance is independent of the feature actual size. Okay, or we can say the considered feature of feature. Okay, so the tolerance is limited to the specified value regardless of the actual size of the feature. Likewise, referencing a datum feature or on an RFS basis means that a centering point of about its axis or center plane is necessary. Okay, so regardless of the actual size of the feature. Okay, so in this, regardless of feature of size, in this particular example, you can see that we have the tolerance apply for 15 mm plus minus 1 m. Okay, so in this this is the tolerance we have provided, and 1 mm of the geometric tolerance is applied. So whatever, let's say here three conditions are there. What is the maximum material condition of this hole? Maximum material condition of this hole will be the smallest hole size, which is dia 14 mm. Okay, and the least material condition of this hole will be the dia 16 mm. Okay, you will see this. So whenever we have the part produced at MMC at dia 14 mm of this hole. Okay, so in this example, we have updated the positional tolerance at a regular feature of size. You have already seen. For the internal feature of size we are considering. So we have different combinations over here. So you can see we have different combinations over here. One is when the part is produced, hole is produced at 14 mm, which is maximum material condition. Okay, so this is the maximum material condition when the part is produced at 14 mm. For this, we have the positional tolerance is of 1 mm. Okay, so when the part is produced at MMC, the tolerance is of 1 mm. Okay, when the hole is produced at 15 mm, the positional tolerance is still 1 mm. Okay, 1 mm only. When the hole is produced at the least material condition, which is LMC, still we have the positional tolerance of 1 mm only. Okay, so on RFS basis, whenever we are talking about RFS, whatever be the hole size, okay, the tolerance value will be the same. Okay, so you can see that in this collective effect. Okay, so all the tolerances we are getting 14, 15 and 16 all diameter, only we get the one positional tolerance, and the datum shift with what we are getting, the whole shift over here is of 0.1 mm. Okay, here you can see 30 mm, so only 0.5 mm shift is seen over here on one side. Okay, so whatever be the size of the hole within the limit of size, the positional tolerance of 1 mm remains same. Okay, and we end up with the max. In this, you can see the maximum shift from the true position. You can see from the true position the maximum shift from on one side by 0.5 mm only. Okay, so whenever we calculate the inner boundary, this red portion is the inner boundary. Okay, inner boundary. So whenever we calculate the inner boundary, here you can see inner boundary is the maximum material condition minus geometric tolerance value. Okay. So you can see the maximum material condition over here is dia 14 mm minus 1 mm. Okay. So dia 13 is the inner boundary. So here we get the dia 13 mm as the inner boundary. You can see over here. So this is also the virtual condition. Okay. So this is the virtual condition. Actually, virtual condition is the worst case boundary that is possible for this part. Okay. So we will understand this concept in a later stage, but till now, what is virtual condition? Virtual condition is the worst case boundary. What is possible for the part to for the mating part, for this part. Okay. So if you will see this part produced at I will say 14 mm, okay, or 15 mm over here diameter, we have a lot of clearance. Okay, so you can see that there is a lot of clearance over here at this position. But the thing is, so but we cannot use this clearance. Okay, why we cannot use this clearance? So whenever we give the regardless of feature of size, okay, whenever we use the RFS, the tolerance are tighter. Okay, so whenever we use RFS, tolerance is tighter. Tolerance are tighter, and through there is a clearance, but it is not allowed to shift further from its true position. Okay, so it is not allowed to shift from the position, from its position, because we have considered this regardless of feature of size. We haven't used any MMC or LMC over here. Okay, so always when we use RFS, when there is a tighter tolerance requirement, okay, for example, in most of the cases when we use the RFS, when we use RFS to create a mold, okay, of, or we create a jigs and fixtures, okay, machine tools when we create, so we use this RFS, okay, and other machining applications to go with the regardless of feature of size only when there is a requirement of the tighter tolerances. Okay, so we considered RFS whenever we require the tighter tolerances. Okay, so inner boundary I have already told you, maximum material condition minus geometric tolerance value. Okay, so this is the inner boundary which is equal to the virtual condition also. Okay, now the next one is maximum material condition. When we apply the maximum material condition, okay, we have understood about the RFS, that when we apply the RFS, now we will understand about the maximum material condition. Maximum material condition, I have already told you, symbol is M within the circle. Maximum material condition defines the worst case condition of the part that will still guarantee because it is still within the prescribed tolerance. Okay, so whenever we use MMC, maximum material condition, we get still we get the extra tolerance or the bonus tolerance. How we get this bonus tolerance, we will be discussing with this. Okay, so the assembly between the pin and hole. Okay, whenever there are two mating parts, one is pin and other is hole. So to enter in a correct way in this, the pin should be enter in a hole. Okay, so when a hole is at the smallest MMC and pin is at its largest condition, or also MMC. Okay, so whenever hole is at MMC means smallest hole size, and pin is at MMC means the largest size of the pin. Okay, so you can see whenever we use the MMC for both the condition for hole and the shaft. Okay, so it is very difficult to mate both the parts. Okay, so we can be sure that we will still be able to assemble that part. So in this condition, we can be sure that we will be able to assemble these both the part. Pin is going to be assembled with the hole. Okay, so thus MMC is widely used in cases where clearance fits are common. Okay, so this is we use where the clearance fits are commonly used. Okay, now we take an example for the maximum material condition where for the internal feature of size. Okay, so now let us have a look of applying maximum material condition for the internal feature of size. So here we added a symbol of MMC. So in this feature control frame, you can see in this feature control frame, I am making this feature control frame over here for the position, dia 1 mm tolerance, geometric tolerance, maximum material condition, primary datum, secondary datum, and tertiary datum. Okay, so the maximum material condition for the hole is over here for the hole is 14 mm. 14 mm is the MMC, 15 mm and 16 mm is the least material condition LMC. Okay, for this hole, because we have 15 plus minus 1. Now in the example, okay, so you can see in this example that when we have the okay, so in this you can see when the hole is produced at MMC, which is 14 mm. Okay, this is the MMC. The positional tolerance available is 1 mm, dia 1 mm. Okay, when the hole is produced at 15 mm, the positional tolerance available here is 2 mm. Okay, when the hole is produced at least material condition 16 mm, the positional tolerance is of 3 mm. Okay, and when the 3 mm. So here when we give the maximum material condition as the when we give the maximum material condition and we move from maximum material condition towards the least material condition, we get more tolerance. Okay, so when the hole is produced at dia 16 mm, which is LMC, we have positional tolerance available is of 3 mm. Okay, because we get the bonus tolerances adding up in this. Okay, so now you can see, and then the positional tolerance value always increases. So in this case, the positional tolerance value is increasing. So here we have the collective effect. You can see over here. So for each size of the hole, the positional shift from the true center. Okay, so this is the true center, and from this center you can see that 0.5 mm it is shifting from the true center in advance. So on one side, so for this, if we calculate the virtual condition, okay, so what will be the virtual condition over here? Virtual condition is equal to the worst case boundary. Worst case boundary will be the inner boundary in this case for the maximum material condition. So inner boundary is equal to the maximum material condition minus the geometric tolerance value. Okay, so maximum material condition here is 14 mm and the geometric tolerance value is 1. So here we get the dia 13. Okay, so this is what we get over here, the virtual condition. Okay, so virtual condition over here is inner boundary, which is the dia 13 mm. Okay, so this red condition. Virtual condition is basically a condition which is the worst case condition when the pin is entered into the hole. Okay, I have already discussed this thing. So when we are learning about the virtual condition and the resultant condition, you will get more clear view of this concept. Okay, so virtual condition is nothing but the inner boundary over here in this case, which is equals to the maximum material condition minus the geometric tolerance value. We get the value over here is 13 mm, and any hole produced within the limit of size will enter into the virtual condition. Okay, and then we have the lot of flexibility in manufacturing. You can see that we have the lot of clearance over here. And in manufacturing, we get ensure that it should be assembled with the other meeting part. Okay, so if your application is that you have to ensure that your part is to be assembled only, okay, and have flexibility in manufacturing. Okay, when there are millions and millions of parts are produced and they need to be assembled with one another. Okay, at that time we use this maximum material condition a lot. Okay, so in this case, you will see most of the automotive components. Okay, automotive parts are there. What we produce are with the maximum material condition MMC. Okay, so finally, as I have said earlier only, virtual condition is equal to the inner boundary, which is maximum material condition minus geometric tolerance value. Okay, now we will understand the next thing, which is the least material condition. Okay, least material condition or LMC, when we apply, this is the symbol L within the circle. When the least material condition modifier is used, it indicates that the specified tolerance applies when the feature of size is at the LMC size. Okay, as the size of the feature of size departs from LMC size, the tolerance is increased by the amount that the size departs from the LMC size. Okay, we take the same example over here. We have the hole, which is the size having 15 plus minus 1 mm. In this case, dia 14 will be the MMC, maximum material condition, and dia 16 will be the least material condition. Now it is saying that when the part is produced at 16 mm, okay, when the part is produced at 16 mm, we have the tolerance of, we have in this feature control frame, first is position, dia 1, least material condition modifier, primary datum, secondary datum, and tertiary datum. Okay. So it is saying that when the part is produced at 16 dia, we have positional tolerance of 0.1 mm. Okay. Now, when the 0.1 mm. So if we move from least material condition towards the maximum material condition, okay, so we get in this further, okay, so in this example you can see now the part we are talking about LMC and we are moving from LMC towards MMC. So at 16 dia we have the positional tolerance of 1 mm. At 15 dia we have a positional tolerance of 2 mm. At maximum material condition, which is 14 mm, we have the maximum positional tolerance, which is 3 mm. Okay. So in the cumulative effect, you can see in this example, we get shift from 0.5 mm. Okay. So collective effect is shown over here where we calculate the virtual condition. Okay. So here the virtual condition is the outer boundary. Okay. So why we are talking about the outer boundary in this case, not the inner boundary? Okay. So the outer boundary is equal to the least material condition plus the geometric tolerance value. Okay. So the bigger the hole, least material condition means size of the hole is bigger. Okay. So in this case, dia 16 mm plus geometric tolerance value, which is 1 mm. So 17 mm will be the outer boundary. Okay. So virtual condition is the 17 mm. Okay. So here circle is virtual condition. So if you see all the holes are within the black, in this black circle. Okay. So here, So here you can see this outer boundary. All the circles are in the outer boundary. Okay. So sorry. Okay. So all these three sizes are within the outer boundary, which is the 16 mm plus 1 mm. So we get the outer boundary, which is the virtual condition. So this is the worst case condition that what we get over here, which are produced are within the black circle and it is touching over the edge. So the worst thing that can happen. Okay. The worst thing that can happen by this, we can always ensure a minimum wall thickness for the part. Okay. So whenever we use the LMC, we ensure that we get the minimum wall thickness. When we require the minimum wall thickness from the part. Okay. So basically this is the distance. This is called the minimum wall thickness of the part. Okay. So if you see the wall thickness is not changing throughout the whole size. Okay. So this distance is not changing. You can see in this part that we are shifting, but still this distance where the minimum wall thickness is not changing. So whenever you have required of the minimum wall thickness application, when we require these application in all such cases, we can go with the least material condition. Okay. So most of the cases where the material thickness is important, where the weight of the material is important, like in aerospace, aeronautical applications, in aerospace applications. Okay. So at that time where the material thickness is the important case. Okay. At that time, we use this minimum wall thickness, which is LMC. Okay. Least material condition. So where the weight of the material is very, very important and we use the least material condition in that case, where the virtual condition is equal to the outer boundary, which is the least material condition plus geometric tolerance value. Okay. Whenever we, now the most important part here is maximum material condition and least material condition. MMC or LMC condition is applied when the geometric tolerance is applied to a feature of size only. Okay. So MMC condition and LMC condition is only applied to a feature of size, FOS. Okay. And we cannot apply MMC or LMC to a feature. Okay. So only we can apply to the feature of the size. Now, geometric tolerance applied to a feature of size. So there are some of the examples: straightness, flatness, angularity, perpendicularity, parallelism, and position. Okay. So only these are the conditions where we can apply the maximum material condition at the least material condition. Now, MMC maximum material condition and the least material condition is applied when the geometric tolerance is applied to a feature of size only. Okay, sorry. Okay, to a feature. In this case, if I am talking about only feature, you can see geometric tolerance applied to a feature. So whenever we are applying these geometric tolerances to a feature, to only a feature, okay, not a feature of size. So MMC and LMC we cannot apply. In this condition, we cannot apply maximum material condition and the least material condition. Okay, whenever geometric tolerances GD&T is applied to a feature, okay, in that case we cannot apply MMC or LMC. Only the case when the geometric tolerance is applied to a feature of size, then only we can apply maximum material condition and the least material condition. Okay, so in this feature of size is the very important thing. So thank you all of you. In the next discussion, we will be further discussing about the next topic in GD&T. Thank you everyone.